Alright, so we are starting section 3, topic 1, piecewise functions. So it starts with, what do you think the term piecewise defined functions means? Anybody have any idea what piecewise defined functions means? Any idea? Nobody? Piecewise defines functions. Basically, it's pieces of different functions. Okay? Instead of just a quadratic function or just a linear function, it's pieces of different functions on the same graph. Pieces of different functions on the same graph. Now, a lot of what we're going to be talking about today, we learned different parts of it when we talked about what our domain and range are doing, describing the end behavior, that kind of stuff. So a lot of this stuff you're already familiar with, okay? Consider the following piecewise defined function, and make observations about the graph. Can anybody tell me something they noticed about the graph? Make an observation. Don't be afraid to talk just because I'm recording it. Yes? Say it again. I can't hear you. There's circles, like you're talking about here? Yeah, like the open circle? Yeah, there's like an open circle and a closed circle. Anybody have any idea what that means? What an open circle means compared to a closed circle? Exactly. If it's a closed circle, that means on this function, x does equal 3 and y does equal 3. That point is included. On the open circle, that means 3 is not included in this function. It's a starting point, okay? And basically, your domain is everything greater than 3, but does not include 3. It's like in the inequality symbols, how we have greater than or equal to. This would be like a greater than, not a greater than or equal to, okay? It's a greater than or equal to or less than or equal to when it's closed. That means it includes that number. What else do you notice? So I have two different types of functions. Yeah, what's this type called? Or it's a piece of a what kind of function? Quadratic function. So we have a piece of a quadratic function. And what's the other piece? What kind of function is it a piece of? Linear function, yes. So over here we have a piece of a linear function. And remember how in previous lessons we had to describe the domain and the range? Well, let's just describe the domain of the piece of the quadratic function. And remember, domain is referring to your x values, right? So what do you think the domain of the quadratic piece is called? The quadratic is that curved piece. Anybody have any ideas? Yes. Negative infinity to positive 3. Do y'all agree with that? That is correct. From negative infinity, because remember when you describe your domain and you're using interval notation, you say what's happening on the left all the way till what's happening on the right. So your x values are coming from negative infinity and they stop at 3. So in interval notation, is infinity or negative infinity, is that a bracket or a parenthesis? Parenthesis, because infinity is always parenthesis. So negative infinity all the way till 3 And would that be a bracket or parenthesis? Bracket. We haven't talked about that a lot, but interval notation, if it includes the number, you use a bracket. If it does not include the number, it's up to that number, but not including the number, it's a parenthesis, okay? But infinity and negative infinity is always a parenthesis, because how can you say what the last number it includes? You know what I mean? So that's just always a parenthesis. So that's how you would write it in interval notation. If you wanted to write it in set notation, remember that's with a fancy bracket, and you would say x such that x is less than or equal to 3, close bracket, because all of your x values on the quadratic are 3 or less than that, right? So those two mean the same thing. This is set notation. This is interval notation. So if it was a multiple choice test, who knows which way they're going to write it. So you would want to make sure you knew what both of those meant, right? All right, let's talk about the domain of the linear function. Interval notation. So if we wrote it like this, interval notation, any idea what the domain of the linear piece would be? Any ideas? Where does it start? At 3. Does it include 3? Nope. So what, we use a bracket or a parenthesis? Bracket. Well, parenthesis, because it doesn't include, it's a parenthesis. So 3 all the way to where on the x-axis? Positive infinity. Just because the arrow is pointing down, that means your y values are decreasing. But if the arrow is going to the right, your x values are going to positive infinity, right? So again, a lot of kids get confused because they look at the arrow and think negative. So be careful about that. If we wanted to put it in set notation, we would say x such that x is what? Less than, greater than, less than or equal to, greater than or equal to, what do we got? Greater than 3. And we don't say or equal to because it's an open circle. Say it again. Got it? So our linear function starts at 3, and as it goes to the right, the direction the arrow is pointing, your x values are getting larger and larger and larger, right? So all of your x values are larger than 3. Everybody cool with that? Where'd I get what? The 3. Okay, so this starting point of the linear function has an x value of 3. But it doesn't include the 3, but that's our starting point. So the way that we say it's not included is by either the parenthesis instead of a bracket, and we say not, we don't have the equal to sign. Okay, but that's its starting point. So from left to right. On this one, the left side started at negative infinity, but it ended when x was at positive 3 before it moved to the next function. Okay? All right, right side of your paper. A piecewise defined function is made up of defined pieces based on different rules for the domain. Consider the graphs of y equals x squared minus 3 and y equals 3x minus 2. Which one of those graphs do you think goes with y equals x squared minus 3? The one on the left or the one on the right? Left, exactly, because it's a quadratic. 2 degrees makes a parabola, right? So this one goes with this. This is a linear function. It goes with the graph on the right. Consider the following piecewise defined function. f of x equals x squared minus 3. Think about it like this. When x is less than or equal to 0, and f of x equals 3x minus 2 when x is greater than 0. So this is like two different functions on the same graph, but you're not graphing the whole thing. You're only graphing the quadratic when x is less than or equal to 0. You're only graphing the line for when x is greater than 0. What's currently shown does not have any limitations on it, okay? So think about this over here. This is telling you how the domain is restricted. So I wrote, this restricts the domain. Y'all see that? Need a better pen. Restricts the domain. So I've got two different functions here, just depending on what my value of x is. The defined domain of the function is x squared minus 3. Of the function x squared minus 3 is, it just wants you to tell you what the restriction is. X is less than or equal to 0. The defined domain of the function 3x minus 2 is x is greater than 0. This means that each of these functions is graphed only for the x values identified in the defined function. So for like x squared minus 3, I'll only graph its values of x when it's 0, -1, -2, -3, -4. If I have x values greater than that, I'm not going to show those on the graph. Okay, I'm not going to show that piece. I'm only showing the piece of the graph with x values that are less than 0 or equal to 0. For the line, I'm only going to graph values of x. I'm going to start at 0, but that's going to have an open circle. That's my starting point. And 1, 2, 3, 4, okay? And we're going to do that on the next page. Make a little more sense to you. Use the graphs of y equals x squared minus 3 for x is less than or equal to 0 and y equals 3x minus 2 for x is greater than 0 to graph the piecewise function. Okay, on your assignment today, you're going to have to graph one of these yourself. So you might have to refer back to this page. So I'm going to graph this piece of the function first. So y equals x squared minus 3 whenever x is less than or equal to 0. So I'm going to make a little table of values. And I'm going to pick my x values. So x is less than or equal to 0. So I'll start with 0, less than. So like -1, -2, -3. That should be plenty of ordered pairs. I know it's a parabola, so I know the general shape. I just kind of need to know its location. And don't you think I could easily substitute these values in my head and simplify? If not, write it down. If I substitute in 0, what is 0 squared? And 0 minus 3 is -3. -1, remember, if you put this in a calculator, the negative and the 1's being squared, so you'd have to use parentheses. Or can we do that in our head? -1 times -1 is what? +1. Minus 3 gives me -2. Substitute -2. -2 quantity squared is 4. 4 minus 3 is 1. -3 quantity squared is 9. 9 minus 3 is 6. So we know our starting point is at 0. When x is 0, y is -3. And because it includes that point, we'll put a closed circle. And all of the other points are included, so you don't have to worry about if they're open or closed. They're all just points on the graph. Closed points. So when x is -1, y is -2. When x is -2, y is +1. When x is -3, y is +6. And I could keep on going if I want to, but I'm probably going to get points that are starting to get off the graph. So that's enough. We know parabolas are symmetrical, but are we going to draw the other side of this parabola? No, because we only want the piece that has x values of 0 and less than that. So we don't draw the other side. We only draw this piece. Is everybody cool with that? Okay. So now let's graph the other piece. Y equals 3x minus 2 when x is greater than 0. So I'm going to make a little table of values. Am I going to use the number 0? I am, because it's going to be my starting point, but I know when I plot it, it's going to be an open circle, okay? Because you still want that as a starting place. Does that make sense? And give me some numbers that are greater than 0. 1, 2, 3. It's a line, so we really only need 2 points, but we're going to do more. So if I substitute in 0, 3 times 0 is, and 0 minus 2 is negative 2. So we got that ordered pair. Plug in 1. 3 times 1 is 3 minus 2 is 1. Substitute 2. 3 times 2 is 6 minus 2 is 4. Substitute 3. 3 times 3 is 9 minus 2 is 7. So we'll start with 0 when x is 0, y is negative 2, and we put a circle there. It's our starting point, but it does not include that point. When x is 1, y is 1. When x is 2, y is 4. When x is 3, y is 7. And of course, there's an infinite number of points we could find, but this is fine. You can do it in your head. Yeah. Yeah, because you know just by looking at that line, it has a y-intercept of negative 2, right? And it has a slope of 3, so you could have definitely plotted it that way and not even done a table of values. I just did it because I wanted to make sure that we didn't just plot a point on the y-intercept, because it's there, but I was wanting to point out that it's got to be an open circle. You don't just go and plot a point and leave it closed, because that would be wrong. Yes. Yes. Let's note some features of the graph. The domain of the piecewise graph can be represented with intervals. We can define interval A as x is less than or equal to 0. So which one are they talking about as A if the domain's less than or equal to 0? My purple piece or my blue piece? Purple, right? Because it has the domain that's less than or equal to 0. And interval B, so this must be B. What is its domain? X is greater than 0. Over interval A, the function is, and it does not lead you to know what they want you to put there, it's increasing or decreasing, yes. You can, just by looking at it, you can figure out what the domain is. Yeah. Over interval A, is the function increasing or decreasing? Okay, we learned this before. Does anybody have any guesses before I remind you what it means? Is the function increasing or decreasing, interval A? Don't look at the arrows. I hear increasing and decreasing. Let me remind you what it means. As you're moving left to right on the graph, your x's are always increasing, correct? But as you're moving left to right on the graph, are your y values always increasing? No. So as you move to the right, don't look at the arrow. If it's pointing up, that does not mean increasing. They're both pointing up. But as I go to the right, are my y values increasing or decreasing? Decreasing. So interval A is decreasing. Interval B, as I move to the right, what are my y values doing? Increasing. Remember that from section 1 or whatever it was? So over interval A, the function is decreasing. And it is increasing over interval B. Now these next two, you're like, I feel like we've already answered this 10 times, and we kind of have, maybe not 10. It's just a redundant, but it's just asking you a question in a different way, okay? The graph is nonlinear or curved when the domain is. So they're saying for the curved part of the graph, so the nonlinear piece, what's the domain? Are they talking about interval A or B? Which one is curved? A. What's the domain? X is less than or equal to 0. The graph is linear when the domain is what? X is greater than 0. Cool? All right. Right side of your paper, there is one closed circle on the graph, which means that particular value, x equals 0, is included in that piece of the function. This illustrates the inclusion of 0 in, it wants you to say x is less than or equal to 0. I meant to use the same color. There is one open circle on the graph, which means that that particular value, x equals 0, is not included. In that piece of the function. This illustrates the constraint that x is greater than 0. So we already talked about closed is included, not closed, or open is not included. Consider the following graphs of piecewise functions. Which ones do you think would be considered continuous? Now, I haven't told you the definition of continuous, but just think about what the word continuous means. Which one of those, or there could be more than one. Which ones or one do you think is continuous? The first one, the middle one, the last one, the first and the last one. What do you think? The middle. Anybody have any other guesses? The middle and the last, or just the middle? Just the middle? Okay, do we think the first one's continuous? No, you are correct. The first one is not continuous. I feel like everyone said the middle one was continuous, and that is correct. It is continuous. But there was some discrepancy on the last one. Do you think that one's continuous? I see a no and I see some yeses.
I said no before because it has the open circles.
You are exactly correct. It is not continuous because it has the open circles, okay? If those circles would have been closed, it would have been continuous. Continuous means you can put your pen or pencil on the graph from left to right and never have to pick it up off the graph to get to the next part. Well, if that little circle's there, that means that value is not included. So I gotta jump over that value to get to the next piece. And then here's another circle, I gotta jump over it to get to the next piece. Okay, so if you never have to lift your pen or pencil up off of your paper for the whole entire function, that's what continuous means. There's no breaks in the function. Obviously the first one's not continuous, because each time you get to a new section, you got to jump to get to it. Okay? Anybody have a question on that? Who wants a question? Who wants a test over continuous? I would. It's pretty easy. All right, page 64. Now you're going to try it. Consider the graph below of a piecewise function. And on your work today, you're going to have to do something very similar. So you might want to actually put some effort into it so you know if you get it or not. Answer questions A through G based on that graph. Do that on your own. If you get it wrong, no big deal. We can erase it and write the right answer. Put what you think it's supposed to be, considering what you've learned already. You can use interval notation or set notation. It doesn't matter. I'm going to write both when I give you the answers. Over what interval is the function increasing? First of all, is it the curved piece or the linear piece? The linear piece, right? So in interval notation, what would that be? From where to where is it increasing? What's greater than or equal to? Okay, x is greater than or equal to what? 1. So that would be set notation. So we'd say x such that x is greater than or equal to 1. And how would we say in an interval notation?
Bracket 1 and maybe 10.
to positive infinity. Yes, exactly. Bracket 1 to positive infinity. I don't care which way you write it. I just care that you know what they both mean. Over what interval is the function decreasing? Interval notation, how would we say that? Negative infinity to 1. So negative infinity would be a parenthesis, and 1 would be a parenthesis also because 1's not included. In set notation, we would say x such that x is what? Less than, greater than, less or equal to, greater than or equal to, what? Are my x values from this point to the left greater than this point, less than this point, what? Less than 1. What is the domain of the non-linear piece? Okay, this kind of like, if you're like, we just had that same answer, don't be confused, okay? What is the domain of the non-linear piece? X is less than 1. This is the non-linear piece. Its x values are less than 1, right? So we could say x such that x is less than 1. Or we could say, in interval notation, what would that be? Where is it starting on the left? What x value? Negative infinity all the way to 1. Not including 1, so it's a parenthesis. Same answer that we got right above it. What is the domain of the linear piece? Anybody? What is the domain of the linear piece? That's the line or the piece of the line. Exactly. And you said it properly too. Good job. X such that x is greater than or equal to 1. And set notation or interval notation would be what? What's my leftmost value of the line, of the piece of the line? Y'all not get it, or you just don't? 1 is include the 1? Yes, so bracket all the way to where? Positive infinity. Okay, range of the function. Range is what? Y values. Is this going to be all real number? And it's talking about, if it just says the function, it does not refer to one piece or the other. Okay, it's talking about the whole thing together. Is it going to be all real numbers for the range? My Y values? So do I have Y values of this function at negative 10? No. At negative 4? No. At 0? Are there any points in my graph that have a Y value of 0? What is the lowest Y value I have? 3. Do I have a Y value on my graph? Do I have a point on my graph that has a Y value of 4? Do I have a point on my graph that has a Y value of 5? Yeah, on the linear piece, but not on the curve because it's an open circle, right? Do I have a point on my graph that has a Y value of 6? Yeah, I've got 2 of them. How about 7, 8, a million, 2 million, a trillion? So what's the lowest Y value I have? 3, all the way up to positive infinity, right? So I would say either 3, including 3, all the way to positive infinity. Now, domain, we go left to right. But if it's range and interval notation, we go lowest to highest. Okay? Or we could say y now, because we're talking about the range, so it's y such that y is greater than or equal to 3. Does the graph represent a function? Explain how you know. Do y'all remember how to tell if a graph is a function just by looking at it? Exactly. It passes the vertical line test. Remember, if you put a vertical line anywhere on your graph, if it touches that vertical line more than once, then it's not a function. If it doesn't, it's a function. Or you could say your domains do not repeat. Passes the pencil test. So is this going to be a function? What about when I get to this point? You say it is or is not? Okay, but the circle's not included. Right. So we technically only have one point that has a x value of 1, right? So it is a function. It passes the test. If those two were closed circles, then it wouldn't be a function because they're two x values that are the same. Okay? But this one's not included because it's an open circle. So it is a function. Tricky. I'm going to say yes because every x corresponds to only one y. If this were a homework question and you said passes a vertical line test, fine. It does. That's fine. Is this piecewise function continuous? No. So that's the end of section 1, but we can get through section 2 today because it's super quick. And your homework assignment / classwork assignment is also on section 2. Okay? But I'll get through it quick. You should have at least 30 minutes in class to work on it. Have y'all seen, and I don't know, maybe even saw it on the PSAT, have you seen problems like this and you were like, what is that? Okay, maybe you didn't question it, but did you see a problem like that before? Never seen a problem like that before? Okay, they're usually on standardized tests. I feel like it's been a long time since I've taken one, but I feel like when I would see them when I was in high school, I'd be like, what is that? I had no idea because I probably didn't learn it yet. This y'all already know is a piecewise function, okay? So we've looked at graphs and piecewise functions already, but now we're going to learn how to evaluate a piecewise function. All right, so I have two different functions. This is what kind of function is this? Linear, so I know it's going to be a line, but it's only going to be the piece of the line that has x values between 0 and 6, not including 0, not including 6. Okay, that's what that means. Your x values are between 0 and 6. What kind of function is this? X squared plus 2, what's that? Quadratic, right? We would only graph, if we were graphing, the quadratic at 6 and x values greater than 6. But we're evaluating. So whenever it gives me a number to evaluate, I have to choose which function am I substituting my value into, and it depends on what your x value is, okay? Yes?
So on the first one, if you did graph it, I know we're evaluating, but if you did graph it, it would be a line segment.
Yes. Yeah, it would just be, wouldn't even have an arrow on the end.
Yeah.
Right. So evaluate f of 2. Remember, when you have f of x, whatever that number in your parentheses is your input or your x value or your domain. So if my domain is 2, which one of those functions am I going to use to evaluate it? If x is 2, which one of those would it? The first one, because it's 2 between 0 and 6. Yeah. 2 is not greater than or equal to 6, so I can't use the bottom one. So I would use the top one. F of x equals negative x plus 5. So this piece right here, you're not substituting anything into that. That just tells you what domain you're using, okay? So I'm finding f of 2. So wherever I see an x, I'll substitute in a 2. And simplify. F of 2 equals 3. So if I were going to plot that point on a graph, what would the ordered pair be? 2, 3. Not 3, 2. 2 is your x, 3 is your y. Input, output, domain, range. Okay? If I evaluate f of 6, which function am I going to use? The bottom one, because this is less than 6, not or equal to. So I'd have to use the bottom function. So I'm finding f of 6 equals 6 squared plus 2. What is 6 squared? 36. Thank you for not saying 12. And I get 38. So if that was an ordered pair, it would be 6 comma 38. Your input 6, your output's 38. What would I use to evaluate f of 8? The bottom one. So I'm evaluating f of 8. So wherever I see an 8, I'll substitute, wherever I see an x, I'll substitute in an 8. And I get 8 squared is 64 plus 2 is 66. Pretty easy, right? Anybody have a question about that? All right, backside. We are gonna, it's a try it, and I'm gonna have you do the try it now. Not number 4, we're gonna skip number 4. But I want you to do the try it A, B, C, and D. And if you finish that before I come back, you can go ahead and try it to beat the tests. Bless you. might have to come over here and check this bottom drawer. That bottom drawer, that cabinet. It's a plastic thing in there. If I have any, that's where it'll be. You're welcome. Goes in your backpack. Okay, let's look at number 5. Which equation will I substitute f of negative 7? The top one, because that's the only place that negative 7 will work, right? It is less than 3. So I'll do negative 3 times negative 7 plus 2 is 21 plus 2, which gives me 23. Is that what y'all got? Awesome. Where will I substitute 3? The middle one. So if my input is 3, my output is 4. It's just an ordered pair. Okay, that's all it is. Don't let that confuse you. You don't have to do any math. When x is 3, y is 4. What about when x is 4? Y is 4. Okay, same thing. That's just another ordered pair on the graph. I didn't mean to put that parenthesis. I didn't mean to put any of that. I don't know what I was doing. 4 equals 4. Where will I substitute in f of 7? The bottom one, because 7 is, it's not greater than 7, it's or equal to 7. So 2x plus 10, that'll be 2 times 7 plus 10. 14 plus 10 is 24. Everybody cool with that? The right side is just a mapping diagram. We've done that before, okay? I told you to start on that if you finish the left side. So you are matching the domain with its range. So I would just take each domain, substitute it into the appropriate equation, figure out what the range is, and you just draw a line to it or arrow to it. So where would I substitute in negative 1? The top one. So that would be negative 1 quantity cubed minus 1. What's negative 1 quantity cubed? Negative 1 minus 1 is negative 2. So when my domain is negative 1, my range is negative 2. What about when my domain is 2? Where do I substitute that in? Top one as well, because 2 is less than, it's not less than 2, but it's equal to 2. So that would be 2 cubed minus 1. What's 2 cubed? And 8 minus 1 is 7. So when my domain is 2, my range is 7. Where will I plug in 3.5? The middle one. I'm going to change colors. So when my domain's 3.5, what's my range? 6. No math to do there. And I'll substitute 5 into where? The top one, because 5 is not greater than 5, but it's equal to 5. So that will be 3 minus 4 times 5 is 3 minus 20, which is negative 17. When my domain is 5, my range is negative 17. And then I'll substitute 6 into where? The bottom one. 3 minus 4 times 6 is 3 minus 24, which is negative 21. And my domain is 6. My range is negative 21. Easy enough, right? Yes. Yes. So we only have one more little piece to do, and then I'll give you your assignment. I told you I'd be finished by 8:30. Anybody have a question about that? So easy. Consider the graph of a piecewise defined function. Okay? Select all statements that are true for this function. Okay, you have to make sure every little piece of it is true before you give a little check. If it's a bracket and it's supposed to be a parentheses, you can't check it. All right, every little thing's got to be correct. So the function is decreasing over the interval negative infinity to negative 1. Is that true? Decreasing over the interval negative infinity to negative 1. That is true. From negative infinity to negative 1, not including negative 1, and notice they gave it a parenthesis. Yep. So if that would have been a bracket, we couldn't select it, but it's not. It's a parenthesis. So that is true. The function is continuous, so we check that box.
No.
Nope. The increasing interval is linear. Is that a line?
No.
No, it's got a curve in there, correct? And that's the increasing function, so no, we cannot check that. The domain of the increasing piece is x such that x is greater than or equal to 1. Is that true?
No.
So close. What would we have to do to make it true? If it was 2, right, because it's x is greater than or equal to 2, so it was really close. The range of the function, so we're talking about range, is negative infinity to negative 1, union with, that means like and also, 1 to positive infinity. The range. Is that true?
No.
No, what would we do to make it true? We just changed one word. What is your range talking about? Your y values. What did they give you?
Oh,
They gave you the domain. Isn't that the domain? So if they would have said the domain of the function, that would have been true. But they said range. That's not the range. F of negative 1 equals negative 1. Is that true? What? Yeah. Oh, you're right. Yeah. If we would have changed that to domain, and you're correct, if that was a 2 as well. I forgot. I didn't notice that. Good eye. Good eye. What were you saying about f of negative 1 equals negative 1? Is that true? It's an open circle. No. If that was a closed circle, it would be true. But because it's open, it does not include that point. That's not actually an x value on the graph. Everything left to that is. How about f of 4 equals 5? Is that true? There's some no's and some yeses. How many people think it's true? Raise your hand. How many people think it's false? Okay, if x is 4, y is 5 is what it's saying. When x is 4, is y 5? Yes. Is it true? Yes. How are you feeling? Good? Okay. So the assignment that I'm going to give you is over both of these sections, 1 and section 2. It's going to be very similar to the notes. So when you get confused, go back through your notes, ask around you before you come asking me, okay? Ask 3 before me. All right. And if you're confused, go watch the Algebra Nation video over this. Obviously I got the notes from Algebra Nation. Amy's really good at explaining it slowly and clearly. Or you can rewatch this video, but you've already seen me, so if you need more explanation, I would go watch that on Algebra Nation.